Welcome to Pre-Calculus. We are on section 0.5, Systems of Linear Equations and Inequalities. So I thought I'd start out today with a short story just to illustrate how, in one particular way, this skill may be useful. So imagine you're on a school trip. You and your friends are riding in the car, listening to music, watching movies. Yeah, I know what you guys do in the back while I'm driving. And finally, lunchtime comes and the driver pulls over and you guys are all eating at Taco Bell. And you and your friends decide, you know what, it's not fun when everybody makes their own order, because if everybody has their own order, the food comes out at different times and then somebody's eating and then somebody's not eating and it's just not fun. We all want to eat together. So you all decide to make one order of all the burritos and tacos that you want for your group of friends. Sounds great, right? So one person goes, takes however many tacos and burritos you guys chose, goes up to the front and buys the whole order. And a little while later, the order comes out and you are all sitting around a table enjoying the tacos and burritos and just jabbering away, having fun. But then tacos and burritos are gone and the driver is not yet ready to go and you've got more time and you're still a little bit hungry. So you guys decide to order a second time. And so you add up a new order of tacos and burritos and another person goes up and pays. And you have all these tacos and burritos, you eat them, and then you get back in the car and you go on the school trip. Well, at the end of the trip, when you're heading back to school, it's not really fair that just two people out of your friend group paid for all the tacos and burritos. And the two orders were not equal, and so it isn't fair the way that the money went. So everybody decides to put in the amount of money they would have paid if they had ordered their own tacos and burritos. And then they would divide the money up so that everybody paid only what they needed to pay. So you go to look for the receipts, and you realize that you threw them away with all the garbage from the wrappings with the tacos and burritos. And now how do you pay people back? Well, you could try to go online, but prices vary from place to place, and you don't necessarily know where you were because only the driver really knows where you were when you pulled off at what Taco Bell. And the people remember somewhat what they paid, and they have their change to show what they paid, but they didn't have the receipt. So if you know how many tacos and burritos were ordered, and how much the total was, how do you find out how much each taco was and how much each burrito was so that you can pay your share and not have somebody else pay for your food and be upset about it later? This is one of the kinds of problems that you can solve using a system of linear equations. You can make an equation for each order, a certain X times however many tacos and Y times the burritos would equal the first amount of money paid, and the same is true of the second, and then you can solve that system and find out the price of each one. So we're going to go over different systems of equations and how we can solve them. We'll cover different ways to solve the systems. And then we'll move into systems of inequalities and how we can solve those. So our first method of solving is to solve by graphing. Now I chose this problem specifically because I wanted to remind you how to graph something that looks like this. Because this is some place where a lot of people get hung up. How do I graph x equals 5? I mean, there's no slope, there's no y-intercept, there's no nothing. Well, what this is, x equals 5. That means x is 5. Y can be 0 and x is 5. 1, 2, 3, 4, 5. When y is 0, x is 5. When y is 4, x is 5. Basically, it doesn't matter what y is. X is always going to be 5. So here is this line. X is always 5. Okay? X is 5. This one is another kind of equation that people have difficulty solving sometimes. They look at this and say, well, there's no slope and there's no intercept. I can't solve it yet. I can't graph it until I rearrange it. And it's true, you can rearrange it. But when you rearrange it, you're going to end up with, well, in this case, there wouldn't be fractions, but you can end up with fractions and different difficulties. Actually, there would be a fraction in this one. Sorry, forgive me for that. There is a fraction in this one, and you end up with difficulties. So another way you can graph this is using intercepts. I will remind you how to graph using mx plus b, the slope-intercept form, in a minute. But I wanted to show you how to graph this one. So if I'm trying to find where this line crosses x, anywhere on the x-axis, the value for y is 0. So if I want the x-intercept, then y will be 0. Okay? And so then I can plug y equals 0 into this, and I get 4x equals 20, x equals 5. So then on my x-axis, I'm going to put a dot at 5. Okay? If I want the y-intercept, then x will be 0. Think about that. If I'm crossing this y, everywhere on this axis, the x value is 0. Okay? So then I can plug 0 in for x, and I get 5y equals 20. That means y equals 4. So then on the y-axis, I can put a mark at 4. And then from here, I can draw a straight line through the point. Now the solution for this problem is right here where the two lines cross. This is a consistent, independent solution. I will explain that more in just a second, but consistent means that it has a solution. Independent means there is only one solution. So this is consistent and independent. And my solution then, the answer is in the form of a point. The x is 5 and the y is 0. This is my answer. Now, it's not always nice to try and graph these kind of problems. Graphing problems can only work if they have nice graphs. Sometimes they aren't so nice like this. And yes, this is a pretty graph because they actually cross through points. I mean, what if they're fractions? If this was crossing like somewhere in here where I'm like maybe a third and maybe a half or something, then I can't be sure of the answer. So then we need to use an algebraic method. So let's solve by substitution. All right. Solving by substitution simply means that I'm going to substitute back and forth. The way I like to think of this method is if I had two balls in each hand and I toss one ball into the other hand and then I toss it back, and it's just tossing back and forth between the equations. So here's my equations, and here are the steps that I will follow over here. Step 1, solve one equation for a variable. It doesn't matter if it's x or y, and it doesn't matter if it's the first one listed or the second one listed. It's just solve one of them for a variable. Okay? So I'm going to look over here at my problem, and here I have 4x, 5y, 1x, and 3. Oops, that's a 3 and 2y. The easiest one here to solve, so I don't have to divide and don't have fractions, would be something with a 1. Because if I solved for like the 2y, I'd have to divide everything by 2 and I'd have a half x. And I don't like fractions because they can get in my way when I'm trying to figure out other things. So when I solve by substitution, I'm going to try my best to solve for something with a 1 in front of it. So this equation in step 1, I'm going to solve for x by subtracting 3 from each side. So then I get x equals 2y minus 3. All right, so now that I have an equation solved for x, I'm ready to go on to step 2. Step 2. Substitute this, meaning the equation we got from step 1, into the second equation and solve. Okay, so I know x is 2y minus 3. This is my important thing. This is what x is. So now I can look at my other equation and put that in the place of x. So instead of 4x minus 5y equals 6, I can change this x out with what I have here. So I'm going to have 4 times 2y minus 3 minus 5y equals 6. And then once I've substituted this into the second equation, I need to solve. So I'm going to solve this for y. I'm going to start by distributing, and I'm going to get 8y minus 12 minus 5y equals 6. And then I'm going to get 8 minus 5 is 3y. And I'm going to add 12 to both sides. 18. Y equals 6. I found one of my answers. Okay, step 3. Put your answer back into the first equation and solve. Okay, so this answer that I found, I need to put back here for step 3. So, x equals 2y minus 3. I'm going to start by writing that. X is 2y minus 3, and then I'm going to take this y and put it in. So then I get x equals 2 times 6 minus 3, x equals 12 minus 3, x equals 9. Now I'm not done. Many people would say, ha, you found x, you found y, we're done. In fact, in your book, it will only give you the first 3 steps. The problem is the answer that you need to give is usually as a point. So my real answer here, I now need to write as a point in xy form. So x was 9, y was 6. There's my answer. So this is the substitution method. Step 1, solve for a variable. Step 2, substitute this expression in for that variable in the other equation. Solve that equation for your second variable. Plug the second variable back into the first equation to find the first variable. Write your answer as a point. Now this is substitution, but we don't just solve by substitution. We also solve things by elimination. So sometimes, like in this case, it's not easy to solve for either x or y. I still could do it, but I'm going to have a big mess of fractions everywhere. Now I also could do several other things, but I'm going to try to solve this one by elimination. Elimination works best if you already have a pair of matching numbers. I chose this problem because I wanted to show you how I can make the numbers match in the first place. So I'm going to look at my coefficients of x and my coefficients of y. If one is a multiple of the other, I can multiply just one equation so that they match and then subtract. But these ones, they're not multiples of each other, and the y's are also not multiples of each other. So I'm going to solve this and try to get rid of my x's. You could solve and get rid of your y's, you'll get the same answer. So I need to find a number that is divisible by 3 and divisible by 2. So if I think of numbers, I can test numbers like if I were to choose 8, 8 can be divided by 2, but 8 cannot be divided by 3. So that is why 8 won't work. The best answer here would be 6. 6 can be divided by 3, and 6 can be divided by 2. So to make this number here 6, I need to multiply this whole top equation by 2. To make 2 into 6, I need to multiply this whole bottom equation by 3. So I'm going to show you what I'm going to get from those. 2 times negative 3 gives me a negative 6x. 2 times 10y gives me plus 20y. 2 times 5 gives me equals 10. Okay, and I do the same here. Don't forget to distribute this 2 and multiply every term. Okay, if you make a mistake there, it will affect your answer and it will become very difficult very fast. 3 times 2 will give me 6x. 3 times 7 plus 21y. 3 times 24. Well, 3 times 20 is 60. 3 times 4 is 12, so 60 and 12 is 72. So now I have my 6's that match, and they are opposite sign. So the whole goal here was to make it so that when I add or subtract these equations, they'll disappear. Because these are opposites, I add. If they were the same, I would subtract. Okay? So I am adding these two equations, and negative 6 plus 6 gives me 0x. 20 plus 21 gives me 41y. 10 plus 72 gives me 82. No x's, no y's. I'm trying to get ahead of myself. All right, so now I have 41y equals 82. Then I can divide both sides by 41, and I get y equals 2. I have my first answer now. So my step 1, this, by the way, I should have been writing my steps. This is step 1. And then adding this was step 2. Okay, step 3. I now need to apply this and put y equals 2 into one of my equations. It doesn't matter which one I put it in. It should give me the same answer either way. So, 2, I'm going to plug into this one because I have a positive number and I like positives better. You can plug into this one because then you'd have smaller over here. It's up to you. You could even plug into these numbers and into these equations and still get the same answer. So I'm going to use 2x plus 7y equals 24. Okay, that's 2x plus 7 times 2 equals 24. 2x plus 14 equals 24. I'm going to subtract 14, so 2x equals 10, x equals 5. Now that I have both x and y, I need to write the answer as a point. Step 4, always write it as a point. 5, 2. That is my answer. But what if I have a bigger problem than just this one? What if I have 3 equations? Okay? When you have 3 equations, you can do either substitution or elimination or even both. I like elimination better, but it doesn't negate the use of substitution. So I'm going to use elimination here at the beginning, and then I'm going to show you that you can switch to substitution on the second part. Okay? So the first part, I'm doing elimination. So step 1 is always make the coefficients match for at least one variable. So I'm going to look here, and I've got positive, negative, positive. I've got the same here. But if you notice, this one has 2 numbers, this one has 2 numbers, this one only has 1 number, and so I'm going to try and eliminate x. This is just my preference. I prefer to do less multiplying. And since I'm going to try and eliminate x, I'm going to use pairs of equations. Now, this one and this one are already, the first equation, the second equation, are already matching and opposite numbers, opposite values. So I can say x minus y minus z equals 7. Negative x plus 2y plus, or minus 3z, minus 3z equals negative 12. Right away, I can look at this and say these match, and so I can add these two equations, and this will give me 0 x's. Negative y plus 2y is just 1y. Negative z plus 3 more negative z's will give me negative 4z equals 7 plus negative 12 gives me a negative 5. So there's one pair of equations. Now, I have used these two. I need to use this one with at least one of the others. So it's up to me which one I choose. I could choose this one and multiply by 3, or I could choose this one and multiply by 3. I want to show you how this works with subtraction, so I'm going to choose the first one. If I were working this problem, I like opposite signs, so I only have to add, and so I would normally choose this one, but I want to show you how to subtract in elimination, so I'm going to choose this one. Know that either choice will work. So I'm going to write the one I don't have to change first. 3x minus 2y plus 7z equals 30. Now, to make this one and this one match, I need to multiply this by 3. So I'm going to go times 3. I need to multiply all that by 3. So 3 times x will give me 3x. 3 times negative y will give me negative 3y. 3 times negative z will give me negative 3z. 3 times 7 will give me 21. Now I'm ready to do my operation. Here, if I were to choose to add, I'd get 3 plus 3 and I'd get 6x. Then I just did this work for nothing. So I need to subtract to make sure that these go away. So then I get 3x minus 3x. And then I get 0x. Because it's subtraction, it's going to go to every single term. So you need to think about this on every term. It may be easier to distribute this negative and add. So I have negative 2y minus negative 3y. The minus negative is plus, so I have negative 2y plus 3y gives me just 1y. And then 7z minus negative 3z. Well, the minus negative becomes positive, so I get 7 plus 3z, and so that gives me plus 10z. And then here I have 30 minus 21 equals 9. Now I'm going to use these two equations in substitution. So this was my elimination part. I now have two equations and two unknowns. Y minus 4z equals negative 5. Y plus 10z equals 9. Now, to To use substitution, I first need to solve one of these equations for y. I'm going to solve this top one for y. You can use either equation, it doesn't matter, but you need to solve one of them for y. So now I have y equals 4z minus 5. Personally, I like solving this one for z. That way I don't have a negative floating out here that I can forget later. I find that my negatives tend to run away on me, and then when I need them back, they're gone and my answers are wrong. So here's my equation, and I'm going to substitute into this one. So I'm going to get 4z minus 5, that's this part, plus 10z equals 9. 4z plus 10z is 14z minus 5 equals 9. And then I can add 5 to both sides and I get 14z equals 14. Z equals 1. So now that I know that z equals 1, I can plug this part back in here. So then y equals 4z minus 5. Y equals 4 times 1 is 4 minus 5. Y equals negative 1. So now I've got two of my variables, and now that I know what z is and what y is, I can plug back into one of these equations to get x. I'm going to choose the first equation. So then I have x minus y minus z equals 7. X minus negative 1 minus 1 equals 7. Well, minus negative 1 is positive 1. So this is plus 1 minus 1. So I have x plus 1 minus 1 equals 7. X equals 7. Now, I am not done. I found z, I found y, I found x, but I am not done. I need to write it as a point. 7, negative 1, 1. And we always write in x, y, z form. All right, one more thing to do and then we can be done with today's lesson. We need to know, how do we solve inequalities? Well, to solve an inequality, there's multiple answers that make this true. If you think of just this one, y is greater than negative x minus 1, 0, 0 would work. And so here would work, 0, 0. And as long as my x is positive, so if I put in x is 5, I'd have minus 5 minus 1, that's negative 6. And y is still 0 at this point. And that would be true. So there is always more than one answer here. Because there's more than one answer, I can't simply say that I can find one point like I did on the others. I have to show multiple points. So here we go. The best way to do this is to solve by graphing. This is in the standard form just like we did earlier, so I'm going to graph it using intercepts. To find the y-intercept, x is 0. So if x is 0, I have y is less than 1. So I'm going to use the point y equals 1. Because you are graphing, just to help you think of it this way, y plus x equals 1 is what you're graphing. And for this other one, y equals negative x minus 1. These become important as you're drawing the line and as you're testing points. So, using this intercept, I found y-intercept is 1. For the x-intercept, y is 0. That means x is 1. So I have this point. Now I can draw this line. To draw this line, I need to know, is it going to be dotted or not? If you have a line, if your equation has one of these, you're going to have a dotted line like this. if you have equals to, less than and equals to, or greater than equals to, you're going to have a solid line. This is our terminology so that we know which kind of inequality you're solving. Because I don't have an equals to here, I'm going to use a dotted line. There's my line. All right. Next, I'm going to graph this equation. This is mx plus b, so we know whatever b is my y-intercept. B is -1, so I'm going to put a -1 here. And then y is here, and that, or y equals mx plus b. M is here, so m is -1. That means as I go over 1, I go down 1. Over 1, down 1. Oops, I need to double check that this is going to be a solid line. So I look back over here, I don't have an equals to, so I'm going to have another dotted line. And these are parallel lines. So this kind of problem, we're going to have a couple of possibilities. Either there's going to be solutions or there may not be solutions. So let's take a look now at what can make these true. So this first equation, x and y are less than 1. So x and y are here. This is the equation we're looking at. We need a test point because one of these sides will make this equation always true. This is the dividing point between the true and the false. I like to test 0, 0. As long as I'm not on 0, 0, it can work as my test point. So 0 plus 0 is less than 1. 0 is less than 1, so that's true. So then this equation is going to shade all of this side. Okay? All of this makes this one true. And I did this on purpose with a light blue. Okay? All of that. Because I want you to understand, this is still a solution for the first one. It may not be a solution for the second one, but it may be for the first one. Then, we have to look at the second one. Okay? Y is greater than negative x minus 1. Well, this line, again, it doesn't go through 0, 0, so I'm going to test the point 0, 0. Y 0 is greater than negative 0 minus 1. Well, negative 0 minus 1 is negative 1, so is 0 larger than negative 1? Yes, that means this point is true. So, for this line, all of this is true. Okay? The only answer for the system of equation is where they're both shaded. Okay? Where they both are shaded is where I can draw my answer. My answer then will be this place in between the two lines. That is the only answer. Because this part will answer only one equation, this part will answer the other equation. The only place where they're both true is in between these lines. What about this kind of problem? Now I've got 3 lines to solve. So, 3 lines, 3 problems. Let's get going. I'm going to graph these faster. Hopefully you remember how to graph now. So positive 1, slope is 2 over 1 up 2. And this has an equal sign, so it's going to be solid. Okay, it does not go through 0, 0, so I can test 0, 0. Y 0 is less than 0 plus 1, that's true. So for my first answer, this side is true. Okay, that's this equation. I like putting a little dot by it so I know which color it was. Here I've got -2 as my y-intercept and a slope of +2, so over 1 up 2. These are parallel. And it's got to be greater than, so I'm going to use 0, 0 as my test point. 0 is larger than 0 minus 2. That is true. So I'm going to, with my blue, say this side is true. Okay. Now for my last point, I have my x-intercept. Y is 0. When y is 0, x is 3. So 1, 2, 3. When x is 0, y is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is not an equals to, and so it's dotted. And I'm going to test 0, 0. 0 is less than 9. That is true, so this is a true statement. So I'm going to bring red in here and say this side is all true. Now, this is starting to look a little bit messy with all the scribbles. But this is very useful to help us understand what part is actually highlighted. I can only take areas where all 3 colors are. Well, in this region right here, I have pink and I have blue and I have red. So my answer is going to be here. I hope you can see how that came to be. There's this side from that line, this side from the other line, from here up, and then from here down. So from these 2 lines, we knew it had to be between, and this line cut it and said it only can be down that direction. All right. I did want to mention something to you real quick about consistent and inconsistent. I'm just going to draw a little picture here. Consistent simply means there is an answer. Okay? It doesn't tell you how many answers. If it is inconsistent, there is no answer. Okay? So consistent means there's an answer. So if you can get an answer, then it has to be consistent. Now, you can have dependent and independent. Okay? Independent is what we've been doing. In a graph form, you would have one solution. Okay? You would also get x equals something, x equals a number, and y equals a number. So say x equals 3, y equals 4. You would get something like that in your problem. If it is dependent, what you are seeing graphically is one line being graphed twice. That means that the answer depends on what you're after. I mean, they depend on each other still. And you would get a statement as you're trying to solve it of something true. You would get something like 9 equals 9 or x equals x. You won't be able to completely solve it because whatever you do, it will go away. Your variables will just disappear. Okay, that's consistent dependent. Now, if you have an inconsistent system, okay, what you will have are 2 parallel lines with no solution. You will get something like 0 equals 38. If you get an answer like this, it's inconsistent and there will be no answer. All right, I believe that is all for you today. Enjoy the lesson, work on the homework. homework. If you have any questions, email me. I will see you in it some form tomorrow.